Hey everybody, hope you're doing well. This video is going to be about modeling probability with an area model, as the title just tells you, doesn't it, right there. All right, well, let's take a little quick review of what probability is and how it's calculated. Probability is always calculated by this fraction. Probability equals the number of desired outcomes divided by the number of possible outcomes. Furthermore, since the number of desired outcomes can never be a number greater than the number of possible outcomes, that is, the numerator of this fraction can never be more than the denominator of this fraction, this means that probability is always some number between 0 and 1. Okay, probability is a number less than or equal to 1, or maybe we might say 100%. All right, so that's the limits of probability there, right there, between 0 and 100%. Now, let's think about this for a second. Let's say the probability of one outcome might be then represented by a number line with 0 at one end, maybe some fractions or percentages along the way, and a 1 on the other end of that number line. That would be one way to kind of visualize the probability of a single event happening or not happening. Now, if you took the idea about this idea and extended it to two outcomes, you might say then we could use a rectangle, or a square actually, to represent the probability of two different outcomes. Each one of those outcomes is a little number line between 0 and 1, and they are perpendicular to each other, creating a square. And the area of that square represents 1. That's 1 times 1, so that's 100%. So our probability of two events happening is somewhere in this box, some fraction of the area of this box. So let's say we've got our first outcome, which we'll call A, has a 40% chance of happening and a 60% chance of not happening. And let's say our second outcome, which we'll call B, has a 50% chance of happening, yes or no. So this is what's called an area model. And it's really, really good for visualizing and calculating, actually, probabilities to questions like, what is the probability of A and B happening at the same time? All right, so if we want to answer that question, what is the probability of A and B? It's actually very simple. It's just about as simple, in fact, as finding the area of a rectangle, which all you do, as you know, is multiply base times height. So we're going to multiply these two numbers. In fact, that upper left-hand little cell in our area model represents where A is yes and where B is yes. So the probability of A and B both being yes would be represented in that upper left-hand little cell of our area model. And it's really easy to find the dimensions of that cell by multiplying the probability of A times the probability of B, which would then be 0.4 times 0.5, that equals 0.2, and that's 20% chance. So there's a 20% chance, according to this, of A and B happening at the same time. Furthermore, every other possible combination of A and B happening or not happening is represented in other parts of this area model. There's a 30% chance of B happening, but A not happening, that kind of thing. And so on to fill out the entire model. And as you can see, when you add up all those percentages together, you get 100%. All right, so that's kind of what an area model looks like, how you set it up. One outcome for one side, another outcome for the other side, and then you divide the sides accordingly to the probabilities, all right, that you have available in the problem. All right, so let's try one of these. Let's say that tomorrow there's a 70% chance of rain and a 25% chance that I will finish work early. So those are two separate things, so they lend themselves really well to an area model. We'll put rain on one side with 0.7 being 70% chance for yes, and a 30% chance, or a 0.3 probability that it does not rain. And then on the other side will be about me finishing work early, and that's 25% yes and 75% no. Now it's really simple to just take the calculator out, start multiplying some of these decimal fractions together, and we can figure out all the different possible combinations of it raining or not raining, or I finish work early or not, in this area model. And then we can answer simple questions like, what's the probability of it being of there being rain and I finish work early? Well, that's what that little upper left-hand cell represents. 17.5% chance, apparently. What about another one? What about probability of no rain and I finish work early? No rain. Well, that would be to the right there, rain being no and finishing work early being yes. That's that upper right-hand box, and that apparently is a 7.5% chance. But we can also answer a different kind of question like, well, let's say, what is the most likely outcome? All right, what's the most likely outcome here? Well, clearly the cell or the part of the area model that has the largest percentage is 52.5%, which means it will rain and I will not finish work early. All right, so this is how an area model works. All right, even though one of those questions is a little bit different than some of the other ones, the one thing that all three of those questions have in common is the word "and." And so I'm going to finish this video right now with this idea about the probability of A and B. And if you haven't caught on to it yet, let me spell it out very explicitly here. Whenever you see a probability question that uses the word "and," you are going to multiply probabilities together. All right, so area models are really good for that because you multiply probabilities just like you multiply base times height for the area of a rectangle. However, it turns out that these area models are good for other kinds of questions also, and that's what I'm going to talk about in the next video here. That will be questions of like probability of A or B happening. Okay, it's a little bit more interesting question. We need a little bit more practice with that, and so that's what's going to be on the next video. So please be sure to watch that one, and thanks for watching this one. Okay, bye-bye.